Alright, so in this problem, we're going to first write, because we're interested in finding to see if it's congruent. We're going to check to see the distance between them. Remember? So remember that congruent means that they're both equal to each other, right? They don't have to specifically, like, let's say this is, like, one can be here and the other one can be over here. But if they're the same length, then that means that they're congruent, right? They don't have to be specifically like on the same points like this. Like they don't have to be right on top of each other, basically. So we're gonna check to see if it's congruent by comparing their distance, right? So let's do JK. JK. See JK. And the line JK, it starts at -3 and 1. -3 and then goes to -1. And it starts there and then it goes to 0, 3. You don't have to plot it. I'll just do a plot over here just so we can visualize it. So -3 on the x, 1, 2, 3, and then -1. So this is -3 and 1. Remember, you don't have to plot it. This is just for us to visualize it. And then this is J, and then K is 0 and 3. So 0 on the x, and then 1, 2, 3 on the y. There you go. This right here, it's K. And then when I go ahead and touch them, that is JK, right? Remember, we don't know the distance of this, right? That's where we're going to figure out their distance. And then let's go ahead and plot the other one. 1 and 1. So we're going to go 1 to the right and then 1 up. It's going to be right here. And then 4, 4. So it's 1, 2, 3, 4. And then 4 up. So it's going to be over here. Like this. So right here, they don't look like they're the same distance. Like this distance. Let me try to see if I can do it in blue. This distance. This right here doesn't look the same as this. Right? But we're going to check to see, because sometimes our image is not perfect. So they could be, but it doesn't look like it. But we're going to either prove it or disprove it. Alright, so let's go back to math. So we're going to find the distance for JK. Right? So we're going to use the distance formula. So the distance formula looks like this. The square root of x2 minus x1 squared plus y2 minus y1 squared. Right, so what I like to do, make sure you right, so what I like to do is make sure you always label them. Believe it or not, this might look like a childish step, but it is not. Always label your variables. This is x1 and this is y1. This is x2, y2. Alright, so make sure you always label them, because trust me, you always make these little mistakes when you don't label them. So always label them. So x squared, x2 I mean, is going to be 0 minus, what is x1? It's going to be -3. So remember right here, there's two minuses, so I have to make sure I write that. Sorry for the messiness, but I don't have a stylus. And it's going to be plus y2. Y2 is going to be 3 minus y1. Y1 is -1. -1. And squared. Alright, I'm going to have to move things around. It's getting way too crazy over here. Alright, so I went ahead and just deleted the graph to give us more space. So let's go ahead and do the inside the parentheses first, not the square. Right, you always do this part first, inside the parentheses. So it's -0, and then we have two negatives. Right here, it's going to become positive. So 0 plus 3 squared plus, and then inside negative and negative make a positive. So 3 plus 1 squared, and then the square root of that. So 0 plus 3 is 3 squared, plus 3 plus 1 is 4 squared, And then right here we have 9 plus 16, which is 25. So it's going to be the square root of 25, which is 5. Okay, so the first one is 5. Now we have to make sure what the next one is, right? I know what the first distance is. So JK is 5 units, right? 5 units. I can just put it here, right? So now we're gonna go ahead and do the other one the same exact way, right? But now it's gonna be what is it? RS. Alright, so line RS, the same exact way, Jimmy. You want to make sure you always label them. Let me see if I can erase these. Always label your variables. Trust me. It might look like a silly step, but you always want to label them. X1, Y1, X2, Y2. Alright, always label them. That's very, very important. Alright, so we said it was, and always write down the formula. Don't do it in your head. X2 minus X1 squared plus Y2 minus Y1 squared. Right. Alright, so let's go ahead and do this. So X2 is 4 minus X1 is 1 squared plus Y2 is 4 minus 1 squared, like this. And then let's go ahead and do it. So 4 minus 1 is 3 squared. 4 minus 1 is also 3. Alright, so now we have 9 plus 9 squared. So 9 plus 9 is actually 18, square root of 18. So unfortunately this is not 5, right? The square root of 18 is not the same. I'm gonna put this, it's not the same as 5. So there you go. That's how you know that these two are not congruent, because they're not the same distance. Okay, remember square root of 18, I don't know what it is, but I can estimate that it's in between 4 and 5. Square root of 18 is it's 4 point something. I know it's in between 4 and 5. How do I know that? Because what is 5 squared is 25, and what is 4 squared? 16. Right? So if I was to ask you this, what is square root of 16? You're gonna say 4. Right? This is 4. What is the square root of 25? This is 5. So 18 is right. It's right in the middle between both 16 and 25. So this is 4.5, because 4 is over here and 5 is over here. So 18 has to be like 4 point, let's guess, 4.3. Alright, this is just a guess, which is not 5. You don't have to do all this though. This is just for further understanding. All you have to know is that 18, square root of 18 is not equal to 5. Therefore, they're not the same distance.